SPI question and answers. What is SPI? SPI is a full duplex synchronous serial communication protocol used to transfer data between microcontroller and peripherals like sensors, displays, EEPROM, and ADCs. It uses four primary signals: master output and slave input that transfer data from master to slave, master in and slave out, data from slave to master, serial clock signal from master, and select the to select the slave here we have a slave select as chip select to ensure that activate the slave for receiving of the data from master. What are the advantages of SPI over I2C? Here the speed and the number of wires, full duplex and multiple slaves, complexity of SPI and I2C will be comparison. Coming to the speed, SPI will be faster up to 50 Mbps. I2C will be maximum up to 3.4 Mbps. Number of wires will be in SPI will be 4 wires and I2C will be 2 wires. And SPI it will be a full duplex protocol. I2C is half duplex, multi-slave. Yes, like both SPI and I2C is a multi-slave communication, but only the difference is SPI will be the data will be transferred based upon the chip select, and I2C based upon the address the data will be transferred. And SPI it will be very simple. So based upon the slave select the data will be transferred, and I2C it is a more complex. Based upon the address the data will be transferred. SPI is ideal for high-speed communication, while I2 is better for multi-device setup with fewer wires. How does master select a specific slave device in SPI? As we know, based upon the slip select line, we are going to select the slave. Each slave has own CS line. The master activates slave by pulling it CS line low. Actually, the data will try to send when it is low. How is data transferred in SPI? Data is transferred bit by bit, synchronized by the clock signal. The master shifts the data out on master output and slave input, and slave simultaneously shifts out the data on master in and slave out. Both devices samples the data on selected clock edge determined by CPHA. How does SPI have built-in error detection? No. SPI don't have built-in error detection. Error handling must be implemented in the software. How does SPI work? Master configures the clock and select the slave, and master sends data via the master out slave in, and slave respond via the master in slave out. Simultaneously, data transfer occurs in synchronization with the clock pulse. After transmission, the master deselects the slave by setting the CS high. So here, SPI requires separate chip select line for each slave, unlike I2C, while using the addressing. What are the four SPI modes? SPI modes are determined by clock polarity and clock phase. So here the mode 0 talks about the polarity and phase is 0, data sampled on rising edge, set up on the falling edge. 101 data sampled on falling edge and set up on rising edge. And mode 2 it is a 10 data sampled on falling edge, set up on rising edge. Mode 3 11 data sampled on rising edge and set up on falling edge. So here the phase and polarities are: phase is specifically the data sample and clock is the clock how it is switching from high to low or low to high. What is the difference between SPI master and slave? Master is the one who generates the clock and select the slave, and slave is the one who is response to the master command and receives the data, and it will send the data via the MISO. Here, the master control communicates while slave only responds when it is selected. What are the limitations of SPI? Here, requires more wires than I2C and no built-in error check. Like I2C, we have the acknowledgement and not acknowledgement in I2C, but in SPI we don't have. It doesn't support multiple masters easily, and uh, slip select increases complexity with many slaves. How does SPI support multiple slaves? Here, usually it have separate lines and daisy chaining, less common. Data flow from one slave to another, but this depends upon the hardware support. I2C is better suited for multi-slave due to address mode, while SPI requires more CS line for selecting of the chips, means the slave to transfer. What are the SPI clock configuration and how and their impact? SPI speed depends upon the clock frequency. Faster clock allows the quicker data transfer but requires stable hardware. Common SPI clock speeds is 1 MHz, 4 MHz, 8 MHz, and 50 MHz. This is the maximum. And clock phase and polarity must match between the master and slave when we are transferring the data. How does SPI achieve the full duplex communication? SPI simultaneously transmits and receives the data because master output and slave input and master input and slave output operate independently, unlike I2C and UART. SPI can transfer and receive data in a one clock cycle. The example of this is when master sends byte via the master output and slave input from the master end, it receives to the slave at the same time. What is the role of pull-up resistors in SPI? SPI doesn't require pull-up resistor like I2C. However, in high-speed application, pull-down resistors may be used on the CS line to prevent noise and unintended activation of the slave. What is the maximum speed of SPI? So here, the maximum speed of SPI depends upon specific devices and implementation. It can ranges from megahertz to it important to consult the data sheet of the devices you are using. So it depends upon the devices that can support the. And how do you debug SPI communication issues? So using oscilloscope or logic analyzer to check the clock and slave signals, how the data is transmitting, and the SPI modes between the master and slaves, and checks whether the slave is responded whenever we are selecting the chip, and reducing the SPI clock speed to check if the timing issue, and verifying a proper wiring and grounding to avoid the noise issue, because the hardware is the complexity on the communication between the devices. Can SPI works without a chip select signal? Yes, but only if single slave is used. The slave remains active as long as the master communicates. However, the multiple slave setups and chip select is necessary to prevent the conflicts. How does SPI compare to UART? SPI is a synchronous, UART is a asynchronous. Speed is up to 50 Mbps, and UART it will be up to 1 Mbps. SPI is a full duplex, yes, and UART is also a full duplex protocol. And SPI supports multiple devices can be configured, but UART we can configure one-to-one. clock required here for SPI is S, and UART, it doesn't require clock. And the error checking in SPI we don't have, but in UART we have a parity bit for checking the error. What are the common use cases of SPI in embedded system? With the help of SPI, we are able to communicate with flash memories, LCD and displays, touch screens, controllers, and high-speed ADCs, and RF transmitter and receiver and Wi-Fi modules can be configured. What is the common issue encountered with SPI for communication? How they can be resolved? Common issues includes here mode mismatch and incorrect chip select control and clock speed issues and signal integrity problems. What are the advantages of using SPI? Advantages include high speed, full duplex communication, relative simple implementation in the hardware and software, and flexible data transfer. What are the disadvantages of SPI?